Today I'll be telling you about stochastic process. Introduction to stochastic process. Process are mathematical models that capture the random and uncertain nature of many real-world phenomena. They are used to study and understand the behavior of systems that evolve over time. Example of stochastic process include in stock market, weather patterns, and population growth. Definition of stochastic process. A stochastic process is a collection of random variables indexed by the time or some other parameters. It represents the evaluation of system over time where each random variables represent the state of system at specific time. The random variables can be discrete or the continuous depending on the nature of system being modeled. Formal definition of a stochastic process is a family of random variables defined on probability space indexed by the parameter t, where t varies over an index set of capital T. Markov property. The Markov property is a key concept in stochastic process. It states that the future behavior of the system depends only on its current state and not on the past. This property allows us to simplify the analysis of stochastic process and make the predictions about future states based on the current state. Markov process such as popular Markov chain are widely used in various applications including finance and biology. The Brownian motion process and the Poisson process are both examples of Markov process in continuous. While random walks on integers and the Gamble-Lund problems are example of Markov process in discrete time. The Markov process form an important class for stochastic process and have applications in many areas. For example, they are the basis for general stochastic stimulation method known as Markov chain Montreal, which is used for stimulating random objects with specific probability distribution and has found application. Types of stochastic process. There are various types of stochastic process, each with its own characteristics. Some common types include random walks, Poisson process, Brownian motion, and gaseous process. Each type has different assumptions and mathematical properties, making them suitable for modeling different types of systems. The term stochastic process is used to describe the time evaluation of statistical phenomena according to the probabilistic law. Random walks. A random walks is a stochastic process where the next step is determined randomly from a set of possible outcomes. It is often used in model stock price where each step represents a change in price. Random walks can either be discrete or continuous depending on the time interval between each step. Poisson processes. Poisson processes are used to model events that occur randomly in time or space. They are characterized by the property that the number of events occurring in a fixed interval follows a Poisson distribution. Poisson processes are commonly used in telecommunication and reliability analysis. Brownian motion. Brownian motion is also known as Wiener process, describe the random motion of particles in a fluid. Brownian motion has wide application in physics, finance, and mathematical biology. Gaussian process. Gaussian process are stochastic process where any infinite number of random variables have joint Gaussian distribution. They are used in machine learning and regression analysis to model complex function and make predictions. Gaussian process often a flexible framework for modeling uncertain and are widely used in various fields. Applications of stochastic process. Stochastic process have numerous applications in various fields including finance, economic, physics, biology, and engineering. They are used to model and analyze stock price, interest rates, population dynamics, epidemic outbreaks, and many other real-world phenomena. The ability to capture randomness and uncertainty makes stochastic process an essential tool for understanding and predicting complex systems. Limit theorems. Limit theorems are fundamental results in stochastic process that describe the behavior of random variables as the number of observation increases. The most famous limit theorem is the central limit theorem, which states that the sum of large number of independent and identical distribution random variables tends to the Gaussian distribution. Limits theorem provides the theoretical foundation for many statistical interference techniques and play a crucial role in stochastic process. Continuous time stochastic process. Stochastic process can be defined in continuous time, where the random variables evolve over a continuous interval. Continuous time processes are often represented using stochastic differential equations, which involves the derivation of the random variables. Example of continuous time stochastic process includes the geometric Brownian motion. Discrete time stochastic process. Stochastic process can also be defined in discrete time, where the random variables evolve the discrete time intervals. Discrete time processes are often represented using different equations which describe the evaluation of system from one step to the next. Example of discrete Example of discrete time stochastic process include the random walk and the auto-regressive moving average models. Importance of stochastic process in finance. Stochastic processes are widely used in finance to model and analyze the behavior of stochastic price, interest rates, and other financial variables. Stimulation of stochastic process. Stimulation is an important tool for studying stochastic process and understanding their behaviors. Stimulation allows researchers to explore different scenarios and test hypotheses and make informed decisions based on their behaviors of stochastic process. Statistical interference of stochastic process. Statistical interference is concerned with estimating and drawing conclusion about the parameters and the properties of stochastic process based on observed data. Techniques such as maximum likelihood estimation and are used to estimate the parameters of stochastic process. Limitations of stochastic process. While stochastic process offers powerful tools for modeling and analyzing complex systems, they also have their limitations. Stochastic models are simplification of reality and make assumptions that may not hold in any situations. The choice of appropriate stochastic model depends on the specific application and the underlying assumptions of the system being studied. Open problems in stochastic processes. Despite significant advancement in the field of stochastic process, there are still many open problems and the areas active research. Some open problems include developing efficient algorithms for stimulating complex processes, understanding the behavior of high-dimensional stochastic system, and extending the theory in incorporate dependency and nonlinear dynamics. Solving these open problems will further enhance our understanding and stochastic problems and their applications. Conclusion. Stochastic processes are powerful mathematical models for capturing randomness and uncertainty in various real-world phenomena. They provide the framework for understanding the evaluation of system over time and making predictions about their future behavior. A stochastic process have application in finance, physics, biology, and many other fields and continue to be active area of research.